Okay, this is the mole ratio introduction, I guess part two. I'm gonna give an example here where there's some specific details and then show you how to go about using mole ratios in order to calculate some other information, okay? All right, so we have nitrogen gas combines with hydrogen gas to form ammonia. So again, we just need to start off with creating a balanced chemical equation, and then we can kind of get to question A here and the information in here. And hydrogen gas forms ammonia gas here. Okay, so they all have gas state symbols here. So we're going to go through and balance it out, and then we can start with the question. So I have 2 nitrogen here, so I'm going to check the other side. I only have 1, so I'm just going to put a 2 in here. All right, and then so nitrogen looks good. Now we're going to check the hydrogens. There's 2 here, but I have 6 altogether here, so I need to put a 3 in front. Okay, now I'll double check again. Nitrogen, there's 2. Hydrogen, there's 6. So we're all balanced out. All right, so now we can start A. I want you to read through, and it says, all right, if you used 2.15 moles of nitrogen gas, so we know that we have, okay, the number of moles of nitrogen is 2.15 moles. Okay, so if we use this much nitrogen gas, so in this reaction, right, how many moles of ammonia could be produced? Okay, so this is the one we have to find. All right, so again, so if we're going to make this comparison from, how much ammonia or nitrogen we have, how many hydrogens we have, to how many ammonias that we can make this comparison if we're in moles. Okay, so we're in moles, so we're good. So from there, because of this balanced chemical equation, I want you to think of it again like a recipe. You need 1 of these, 3 of these, and it makes 2 of these. Okay, so if I have, if I know exactly how much nitrogen I have, I can actually find how much ammonia I have by using these coefficients that are in front of the compounds in this balanced chemical equation. So the way you're going to do that is you're going to start analyzing the ratio here. So if I look at nitrogen to ammonia, and we look at the ratios that that you need to, how much of this do you need to dump in to make how much of that? So it is a 1-to-2 ratio. So for every 1 molecule of nitrogen that I throw in, I will get 2 molecules of ammonia forming here. All right, so it's a 1-to-2 ratio. So that means if I know how much of nitrogen that I have, in order to figure out how much ammonia I have to multiply by 2 to get to 2 here. All right, so that's what we're going to do here with the value of the moles that we know here from our question. So we have, we know 2.15 is the nitrogen here. So if I multiply this by 2, how much of ammonia will I have? Well, so I multiply 2.15 times 2, and I'll get 4.3. Okay, so therefore, how many moles of ammonia will be produced? So the amount of ammonia is 4.30 moles, like that. Okay, just add another digit there. Okay, so that's what you need to do. So that's how I come up with this ratio here. I'm using this balanced chemical equation. So with the other video, I just kind of made up some random questions, and I think that's why it may have been confusing. So we'll just kind of go through these steps here with a specific example this time, okay? All right, so let's try the next one. Here's part B. So again, we're still using the same chemical reaction equation here, but the scenario is different now. We have different amounts of, we actually know the information about ammonia this time, so let's write that in here. Okay, so we know that there's 15 moles of ammonia. Okay, so if that was produced, how many moles of nitrogen would be required? Okay, so we need to find nitrogen this time. So last time we knew nitrogen, so we could kind of use this balanced chemical equation to, and use the ratios for the coefficients to figure out ammonia. But this time we know ammonia, we need to go and find nitrogen, okay? All right, so again, I want you to take a look at the ratio. So I always put the one that I know first. So I'll put nitrogen first, okay? Or sorry, ammonia first, because we know that one. But we don't know nitrogen, okay? So then I'll go, okay, it's a 2-to-1 ratio here, all right? So 2, and then there's no number here, but there's a 1 there, okay? And then, so what are we noticing when we go from what we know to the one we don't know? Well, 2 became 1. So instead of multiplying by a number, I ended up dividing by 2 to get to 1, okay? So that's the relationship that they have to each other. It's, if I have 2 of these, I only have 1 of these to start with, okay? So it's, yeah, so like you have to like divide it in by 2 or like cut it in half, think of it that way. All right, so now if we put in our value here, so we know we have 15 of this one, okay? So if we know it's a 2-to-1 ratio, we need to divide by 2. We're going to take 15 and divide it by 2, and then we get 7.5. Okay, and so therefore, that's the amount of nitrogen that we have, okay? All right, so again, you have to have that balanced chemical equation, and that's how we, like, if we know one of them, we can find the rest of the stuff that's in the chemical equation here. Okay, so we know information about the moles of just the one substance here. We can find even hydrogen here and nitrogen here, okay? And again, it's all because it's like, if I have one of these, I have 3 times as many as these. If I have one of these, I have 2 times as many of these. Or if I go back the other way, I had 2, I only have 1, so I have half of what I had, okay? And then this 3 to 2 is going to be trickier, so we'll do that one next. Go to C now. So again, we have the same balanced chemical equation, but we have a different scenario here where we have, we know the amount of ammonia this time, so we know it's 0.6 moles of ammonia. Okay. And we are now trying to find hydrogen gas this time. So we like to find this info here. All right, so this is the trickiest one where it's not a, like a 5-to-1 or 3-to-1. It's always nice when there's one of them's a 1 ratio. In this case here, we're looking at, some other value here. So again, let's just write the first one that we know. We know information about ammonia. We are trying to find information about hydrogen. Like, how do they compare? Okay, so like, again, when we were comparing with nitrogen, it was like, oh, there's 1 nitrogen, there's double of ammonia that forms, okay? But when there's 2 of these and 3 of these forms, what's the relationship that they have to each other here? Okay, so we have 2 of these. If 2 of these form, we had 3 of these involved, okay? So how do we then take our 0.6 and use this ratio to calculate this one here? So this is what I'm getting everyone to do. Write the one that you know here, and then I want you to get it so that it's 1 to something, because you want to compare, well, if I have 1 of these, how many hydrogens would I have? Okay, because right now I have 2 of these, and then I get 3 hydrogens. So if I have 1 of these, it's a little easier to figure out, what do I multiply by, or do I divide, and so forth. So if I take this and drop it to 1, I have to divide by 2 to do that. So that's what I'm going to do here. I'm going to divide this by 2, and then I can get a comparison of a 1 to something ratio here. So when I do that, I'll take 2 and divide by 3, and what that is as a decimal is, it's a 1 to 1.5 ratio. So if I have 1 ammonia, I have 1.5 hydrogen. Or you can say, I have 2 ammonia, I have 3 hydrogens. So in the end, you ended up multiplying by 1.5 here. Okay, so now going back to the actual problem here, you have 0.6 of this one. How much of this one would you have then if you know it's a 2 to 3 relationship or a 1 to 1.5 relationship? Okay, so you know you have 0.600 moles of this one. How much of hydrogen would you have then if you know it's a 1 to 1.5? Okay, so you just multiply by 1.5, or you know it's like, oh, I take like 0.6 plus half of 0.6, which is 0.3, and you get to your answer, okay? So you end up with 0.900 moles. And then, write your final statement. But the key thing is just get comfortable with this whole ratio idea today. And then just let me know if you still have questions.